Welcome back. Let's talk about some regions at risk of mass wasting specific to the U.S. Next section, we'll get into more a global look at it. So, what location might be at risk for having mass wasting events? Well, typically, the first thing you need is some slope, some hills, and or mountains. So, anywhere that has significant slopes, mountains, hills, they're at risk. So, kind of need that. From there, you have to look at some of all the other factors, but, in wet climates or in dry climates, in warm places and cold places, mass wasting can occur. But probably the, first thing you need is some slope. So there are some factors that are expected to increase mass wasting activity outside of nature. And that can include urbanization and development of mass wasting prone areas. So living and working and building houses near places that, where mass wasting could occur. So that's going to make it worse. You're disturbing the ground. If you're building on top of a slope, on top of a hill, you're adding pressure to it, which can cause mass wasting. Cutting down trees. So whether, wildfires are natural, but as humans, we're logging, for wood or just cutting down trees to build. So tree cutting in mass wasting prone areas, you're removing that anchor system that could also increase mass wasting activity. And then, climate's a natural big factor, but if climate is changing, well, that's also going to have a big impact on it. So this is a map of the U.S. that shows, well, let me just explain the different colors. So red, the dark red color is, these locations have a high incidence, meaning they have a lot of they have a lot of mass wasting events. Orange is moderate incidence, so they have a medium amount, but they're very highly susceptible. So you really want to be careful. So high incidence, high susceptibility. Orange, moderate incidence, but it still has a high susceptibility. They could be much more than there is. And then the yellow also has a very high susceptibility, meaning it could happen, but rather low incidence in general. But they could happen a lot. So the red is what you want to look out for. Orange, also kind of bad. Yellow, we're still getting there. But one thing to point out, the largest red sections you'll see are going to be over in this area of the eastern U.S., kind of in this area in the central U.S., and this little region over here in the western U.S. What could that be? What could be there that might cause such a high incidence of mass wasting events, meaning that happens a lot here? Remember, the first thing we need is some slope, some sort of hills, mountains, some sort of incline. Well, guess what's in these three areas? You have the Appalachian Mountains over here on the East Coast. You have the Rocky Mountains over here. And then you have some of the coastal ranges of California over here, Sierra Nevada and the Cascade Ranges, some of the other coastal ranges of California. Well, go figure. The places around the U.S. that have the most mass wasting events are the places that have the most mountains. Go figure. But they can still, happen in other places. Just kind of looking at a satellite view, again, there's the Appalachian Mountains here, the Rocky Mountains, and the coastal mountains of California. Now, the interesting thing about pretty much all hazards in this class, they're always linked to something else. So mass wasting can be linked to almost any other hazard. Earthquakes can cause mass wasting events. Volcanoes can cause mass wasting events. Storms can cause mass wasting events. Wildfires may cause mass wasting events. And in turn, mass wasting might cause flooding or tsunamis, depending on where that mass wasting occurs. So yeah, kind of linked. And one of the common threads between some of these is water, storms, wildfires, lack thereof, flooding, tsunamis, earthquakes and volcanic activity, more plate tectonic driven. But Yeah, anytime you have water, bad things can happen. So just to briefly give you an example of wildfires and how they may cause mass wasting events, this is just a interesting little thing, and we'll look at some videos in lecture, but I wanted to point it out to you. So, and this happened a few years back in Utah, just outside of Salt Lake City. A wildfire in the area. You can see the mountains in the background here. These mountains kind of keep going this way. There's some small wildfires. So wildfires in that area burned vegetation, removed that anchor, loosened the earth up on these steep slopes right next to this neighborhood, and it knocked loosened this big boulder on the mountainside, and it came rumbling down and stopped right in this person's front yard. We'll look at this more a little bit in lecture. So, what about Arizona, though? Let's focus in on Arizona. So let's look at some facts as far as mass wasting events occurring in Arizona, because we don't typically have a high incidence. In a few spots we do, yes, but overall not so much. Even though there's a lot of slopes and a lot of hills here. But let's just run down the numbers. In Arizona, more than 6,300 mass wasting events have been identified going back through geologic history. When we look at the speed at which these mass wasting events in Arizona have occurred, they could occur fast, so measured in miles per hour, or slow, inches per year. So we get from creeps to fast landslides and such, and debris flows. Mass wasting occurs in all 15 of Arizona's counties. However, over half, 50% of mass wasting events occur on tribal lands, typically up northern Arizona. If we looked at those 6,300 mass wasting features that have been identified in Arizona, if we kind of looked at the area that they covered, their collective footprint of the deposits that they've left on the ground, it's more than 770 square miles. That's an area equivalent to Phoenix and Tucson combined. So it's a lot. So we have a lot here. Red is high incidence, orange moderate incidence, yellow low incidence. So we tend to have a lot of high incidence, again, mostly up north and mostly in and around tribal lands, where over half of it has occurred. So high incidence around these locations, moderate incidences, and then kind of all the other yellow is low, but still, it's still there. If you look, almost all of Arizona is covered in a low mass wasting incidence. So it could happen anywhere, especially since flash floods can trigger things like debris flows, and flash floods are brought on by heavy seasonal rain, like our monsoon that we have here in the Southwest. So since a flash flood, which could be triggered by heavy rains, could also pick up enough material to be considered a debris flow, it could happen pretty much anywhere. It could happen right here in Avondale. Just going back the past few years, some more notable ones, the ones that I know I picked out in the news as they would kind of come up. So almost a couple of years back, US Route 88, which runs just, it makes up the Apache Trail, if you've ever driven that, which is now closed. But as it kind of heads into Roosevelt Lake, there was a mass wasting event here right on US Route 88, as you can see it. You can see it from the sky here. What does this look like? What kind of event does this look like? Want to give it a shot? To me, it kind of, I don't know. I see some blocks there. More maybe like a block slide. Maybe it looks like maybe some translational landslide, block slide. Again, remember, typically when you get a mass wasting event, it's a complex aggregate of a few different things. So it looks like maybe a translational landslide, but with some bigger block slides. To be determined. This going back almost 10 years, but quite an interesting one on U.S. Route 89. Man, got to watch out for those Route 80s. $25 million in damage just south of Page, Arizona, up north Arizona. So this is, what it should look like, and this is what it looks like. You can kind of see this whole material just it looks like some sort of maybe translational landslide, rotational landslide. It looks like it kind of comes down, and then I'm just imagining under the road it kind of curves under, so kind of this slump. And you can see the terrain is very, very, very steep. Right? U.S. Route 87. Let's just keep it, or State Route 87. Let's keep it in the 80s. Let's keep it in. Man, if you're driving on a Route 80 in Arizona, I guess watch out because that means landslide. So $18 million. So this is in the Tonto National Forest, so just south of Payson. You can kind of see this material breaking away. And I think some of the material did cover the road, but they were able to kind of sweep it off. This looks like maybe a translational landslide or yeah, that's kind of what it looks like to me. But what they're probably going to have to do, or what they did, because this was a number of years ago, this is an unstable slope, so they have to stabilize it somehow. We'll talk more in another section about how you can do that. And then maybe probably the most famous mass wasting event in Arizona, and it's been studied. Oftentimes, it's cited in geology textbooks, which we don't use. But it's the Marcus landslide. It's just over the McDowell Mountains in Scottsdale, Arizona. So there was a mass wasting event, and it occurred here, and this material kind of slid off in this direction, and this is all that slide material. More on that at another time, as we might have projects that cover this specific event. So one of our projects for class might cover this. So we might hear about this a little bit later in the year. I'll leave that for them. But yeah, there's dangers of mass wasting events in Arizona. One of the biggest ones is typically with debris flows. As recently as 2017, a post-wildfire flash flood up in the Tonto National Forest, just outside of Payson. So wildfire, so land was stripped bare, burnt stuff all over the ground, a lot of rain, causing a flash flood, mixed with all that material, that loose material, that burnt material, causing a debris flow. It swept over and killed 10 people that were in a swimming hole, in the Cold Spring swimming hole just north of Payson. So there was this channelized debris flow, so this debris flow flowing in this channel. So the debris flows and the associated flash floods are responsible for most mass wasting related deaths in Arizona. So unfortunately, that's what happens. So this is the Cold Springs area. So there was a channelized debris flow that just kind of came through, and 10 people died. Flash floods, as we learned in a previous unit, can happen. Can be sparked by rain 100 miles away, and that rain collects in the channel, and as it goes through the channel, it picks up material, turning into a debris flow. If you're caught in that, that's about it. This isn't necessarily from that particular debris flow event, but it shows you what happens when a debris flow stops, sometimes known as a mud flow or a mudslide. When it stops, it turns pretty solid. All right, when it stops, it's hard ground. It's dirt mixed with rocks and a number of other things. So it looks like this debris flow occurred, and it looks like I can see some tractor or some bulldozer tracks. Some debris flow covered this road, and the bulldozer came in and had to clear the path. So this stuff can form hard, solid concrete. So if you're stuck in it, you're stuck in it. All right, let's go ahead and pause there. But before we go, let me give you part of the super secret code. It is the number 1. You got me? The number 1. All right, so when we come back, we'll talk about impacts on society from mass wasting events. This one's going to be a little bit longer, so we're going to break this one up into a few videos. I'll see you back here in just a second.